Good morning, mathematicians. Today we'll be doing lesson 9.2, converting easy fractions to decimals and percents. Today's objectives are to reinforce renaming fourths, fifths, and tenths as decimals and percents, and to introduce solving percent problems by using equivalent fractions. Let's get started with our warm-up. Today we're going to rename fractions as decimals and percents. So we have over here 36 hundredths, 87 hundredths, and 19 hundredths. Go ahead and rename each as a decimal and a percent on your whiteboard now. 36 hundredths could also be written as 36 hundredths and 36%. 87 hundredths could also be written as 87 hundredths or 87%, and 19 hundredths could be written as 19 hundredths and 19%. Go ahead and erase your boards and we'll get started on the next set. We know that 3/10 can be written as 3/10 like this, which is the same as 30%. 1/2 can be written as 5/10 and can be written as 50%. And 4/5 we know we can turn into tenths by multiplying by 2 over 2, which equals 8/10, so I could write it like this, which is the same as 80%. Go ahead and erase your board and then set it off to the side. Now we'll be turning to page 252 in our math journals. For today's math message, let's complete problem number 1. It says, Alfred, Nadine, Kyla, and Jackson each took the same math test. There were 20 problems on the test. And we can see in our 100% box, 100% is 20 problem test. And number 1 says Alfred missed half of the problems. He missed 50 hundredths of the problems. That is 50% of the problems. How many problems did he miss? 1/2 of 20 equals blank. 50% of 20 equals blank. Go ahead and solve this on your own now. One thing we know is that it's pretty easy to rename a fraction as a percent when the denominator is 100, such as 32 hundredths. We know then another name for 32 hundredths is just 32%. There are other fractions such as 1/2, 1/4, 1/5, and 1/10 that can be renamed as percents pretty easily as well. For our half, we can think of how many out of 100 is equal to 1/2, and we know that 50 out of 100 is equal to 1/2, which is where we got that 50% right up top. And because we know that half of 20 and 50% of 20 mean the same thing, we can easily solve that half of 20 would be 10 of the problems, and so 50% of 20 would be 10 of the problems as well. And then how many problems did he miss? He missed 10 problems. Let's also take a look now at problem number 2 on the same page. It says Nadine missed 1/4 of the problems. She missed 25 hundredths of the problems. That is 25% of the problems. How many problems did she miss? 1/4 of 20 equals blank, and 25% of 20 equals blank. Turn and talk with your math partner about how you would go ahead and solve this problem. Then do it on your paper. Well, we know that finding 1/4 of 20 means that we're going to divide 20 into 4 equal pieces. So 20 divided by 4 equals 5. So then again, 25% of 20 also equals 5, which means that she missed 5 problems. looking over here where it says 1/4 or 25% is shaded, we know that 1/4 is equal to 25% because when looking at this grid, we know that when 1/4 is shaded, 25 squares are colored in. So that's the same as saying 25 out of 100, or 25%. When you get done with your journal pages today, you will pair up with somebody else who is also done at the same time and play Rugs and Fences. It's a game that helps us with our perimeter and area, and it's called Rugs and Fences because our rug covers an area and a fence goes around the perimeter, so we can think of area as rugs and perimeter as fences. Let's read through the directions so everybody knows how to play this game before we start. First, it says we'll need our polygon deck A, B, or C, so you'll choose A as the easiest. You can see over here you would be counting squares. For B, you would be using formulas to figure out, and for C, those are the toughest. I would suggest that most of us wouldn't choose C right now. You'd have the area and perimeter deck, and you will have a record sheet for each player. This is a 2-player game, so you will have a partner, and the skill is to calculate area and perimeter. The objective of this game is to score more points by finding the perimeters and areas of polygons. To start out, you need to select one of the polygon decks, shuffle the deck, and place it picture side down on the table. Then, you need to shuffle the deck of area and perimeter cards and place it word side down next to the polygon deck. Players will take turns. At each turn, a player draws one card from each deck and places them face up on the table. The player finds the area or perimeter of the polygon as directed by the area and perimeter card. If a player's choice card is drawn, the player may choose to find either the area or perimeter of the polygon. If an opponent's choice card is drawn, the opposing player chooses whether the area or perimeter of the polygon will be found. A player records a turn on his or her record sheet. The player records the polygon card number, circles A, area, or P, perimeter, and writes a number model used to calculate the area or perimeter. The solution is the player's score for the round. The player with the higher total score at the end of 8 rounds is the winner. So let's now take a look at a couple examples before we go off. Here we have our record sheet that we would be using, and here's our example here. So it says Amma draws the 2 cards shown here, and we can see her cards are here. So here's this one and this one. It says Amma may choose to calculate the area or perimeter because her card here says A or P, player's choice, so she gets to choose. Amma counts unit squares to find the area, so she counted and got 20 square units. Amma counts unit lengths around the polygon to find the perimeter. Perimeter equals 24 units. Amma records card number 3 and circles P on her card sheet. So let's take a look here at her record sheet. We can see that she had card 3, so she recorded card number 3 here. She knew that the area was 20, perimeter was 24, and she wants the higher score, so she decided to calculate the perimeter. So she circled P, and she wrote down her number model, 10 plus 10 plus 2 plus 2 equals 24. And her score then is just that ending score of 24. Now it would be her partner's turn. And it says, Parker draws the two cards shown here. So here's one, here's the other. He finds the area of the polygon by using the formula A equals base times height. He records card number 17 and circles A on his record sheet. He writes the number model 5 times 7 equals 35 and earns 35 points. So this time his card specifically said find the area of the polygon, and this time he couldn't count because he just had the sides 7 and 5. And again, here was his card 17. Parker would go ahead and record his score on his own card. So he would go ahead, if this was his scorecard, he would write card number 17. He did the area. His number model was 7 times 5 equals 35, and his score was 35. You and your partner would take turns then until you each had completed 8 turns, and then you would calculate your total score seen at the bottom to decide who wins. I would now like everybody to make sure they have their learning journeys out, and make sure that you have today's date written in the date spot on top. Then, as always, everybody should have this out as you do your activities for the day and be checking them off until you're all completed. So we can check off mental math. We still have to finish part of page 252. You also have to finish page 253. We have to make sure math boxes 9.2 are finished. And then when you're finished with those 3 things, you may join a partner to play rugs and fences for extra area and perimeter practice. If you get finished with all of that, if you're activity B, you can do units 9 and 10 blend space, practice B and C. And for activity C, units 9 and 10 blend space, practice F. Make it a great day.